They calories, but it does not have taste to us, okay? And then they also gave sucralose, which has taste but does not have calories. And then they basically gave it where they lined up, where you got the same amount of sweet from sucralose as calories from maltodextrin, and where you got the differing amounts. And the take home is, when it lines up, our body responds more. When it doesn't line up, all our responses are tamped down, and they looked at a bunch of different responses, okay? So here we're looking at 2 experiments, giving 75 kilocalories of sucralose, 112, 150. So let's start with the first one. They're doing an fMRI when they give 75 kilocalories of sucralose. And with these other bars, this is how much maltodextrin they gave. So the fMRI has the most effect when the sweet taste matches the calorie taste. Does that make sense? And it actually goes down in both directions when it's off, okay? Then they looked at change in resting energy expenditure. This is the big thing one of the big things about losing weight. So if I had to boil it down to like what I tell my 7-year-old, well, in a healthy manner, is that basically it's calories in. By far, we can consume way more and again, I'm talking all about reducing obesity. You can consume way more calories than it's easy to burn off. But then also after that, a secondary thing is what's your resting metabolic rate. If you're running a lot, clearly that helps. So it's in that order. Okay, so when you look at the resting energy, again, it's increased more when the sweet taste matches the calorie taste compared to when it does not. Even though over here at 150, you're actually getting more calories, but you're not getting as much sweetness, okay? So then experiment 2, they all kind of follow the trend. 112, again, you have the most signal for resting energy expenditure when they match up, and it's lower when they don't match up. And then when you go to the high extreme of this is looking at blood glucose. Again, the higher blood glucose change is when they match up than when they don't match up. Again, notice at 150, you're actually getting more calories, but you're not having as much of a blood glucose change because you didn't have the sweet signal. And then at 150 kilocalories, the resting energy expenditure, again, was the most when the taste and calories matched up compared to going down. The show of hands, did that make sense to people? Okay, not so much. Okay, so there's a few ways this happens. One of the take-homes that I'll follow through with on the next slide is those receptors we have that detect sweet, those aren't just in our mouth. We've now found they're in our gut. So in our gut, we're also detecting sweet, and our metabolism is changing based on that. Okay? Yeah.
So basically what you mean is that when you have these artificial sweeteners that have maybe more calories, but that your body won't release the right amount of, won't have the proper blood sugar, so then your body doesn't know how much it's actually taking in, so it's less.
Yeah, your body basically doesn't know. So let me re-say what you said a few times. First of all, when you have artificial sweeteners, you're having no calories or very low calories. So you're having the signal that you have calories from the sweetness, but you actually don't have them. And so if you are eating some calories with a Diet Coke, it's again off, and your body's not responding correctly in all these ways. Your resting energy expenditure isn't responding as much, your blood glucose isn't responding much, and to me the most interesting, the fMRI, because that is the one that you're probably not feeling satiety, you're not feeling full as much as you should, and that would reduce you eating more, okay? You don't need to worry about this. The take home here is they looked at the difference, and 0 to 150 was bad. The red line, it's when does taste and calories not match up. It's kind of the same information, just